Hello everyone, good afternoon to all of you. Previous video रे मैं up to hydrates of nitrogen family पर्यंत पढ़िथिले तार properties. In this video we will discuss formation of oxide, means group 15 elements forms which type of oxide and forms oxide of which type. Let us see. Group 15 elements combine directly or indirectly with oxygen and form oxide. Group 15 element directly हो by indirectly हो oxygen सहित समान combine है कि formation करंती oxide. Nitrogen forms all oxides having oxidation from +1 to +5. Nitrogen all oxide formation करे having oxidation state from +1 to +5. You can see the table, that is from oxidation state to +1 to +5. See, nitrogen forms from +1 to +5 oxidation state. That is, in +1 oxidation state it forms nitrous oxide, which formula is N2O. Second one is +2 oxidation state. The second oxide is nitric oxide having formula NO. Then third oxidation state, that is +3 having formula N2O3. Then fourth oxidation state +4, that is N2O4, which is known as dihydrogen tetraoxide. Then comes to fifth oxidation state, that is +5 N2O5, which name is dinitrogen pentoxide. Nitrogen forms nitrous oxide having +1 oxidation state, nitric oxide having +2 oxidation state, dinitrogen trioxide having +3 oxidation state, dinitrogen tetroxide having +4 oxidation state, and dinitrogen pentoxide having +5 oxidation state. Nitrogen is the only element in group 15 which can show from +1 to +5 oxidation state. Besides nitrogen, all the elements of nitrogen family, that is group 15, mainly show +3 and +5 oxidation state oxides. Besides nitrogen, all the elements of nitrogen family can show +3 and +5 oxidation state. We already discussed the oxidation state of nitrogen family, that is +3 and +5 oxidation state they will show in, that is phosphorus, arsenic, antimony and bismuth. Their +3 and +5 oxidation state oxides are stable, that is they forms phosphorus P4O6, they exist in dimeric state. P4O10, this is also a dimeric state, but arsenic, antimony, bismuth, they are existing as their usual form As2O3, Sb2O3, Bi2O3, then As2O5, Sb2O5 and Bi2O5. That is, except nitrogen, all the elements forms on oxides having oxidation state +3 and +5. Then all the oxides of nitrogen except N2O and NO and phosphorus are strongly acidic. These two oxidation states, that is +1 and +2, they are neutral in nature. Besides these two oxides, that is N2O3, N2O4, N2O5, and all the oxides of phosphorus, that is P4O6, P4O8 and P4O10, these oxides which is under the dotted line are acidic in nature, because we know on moving down the group acidic nature decreases, basic nature increases. So the oxides of nitrogen, that is having oxidation state +3, +4, +5, and all the oxides of phosphorus are strongly acidic in nature. Oxides of arsenic are weakly acidic. Acidic nature decreases, so all the oxides of arsenic are weakly acidic. Oxides of antimony are amphoteric. Oxides of antimony are amphoteric because in case of antimony, acidic nature decreases and basic nature develops. So these oxides show both acidic and basic properties. So these oxides are amphoteric in nature. Then last element, that is bismuth. Oxides of bismuth are weakly basic in nature. Bismuth oxides are weakly basic in nature. Next comes to another point, that is nitrogen has the ability to form p-pi multiple bond, but other elements, that is phosphorus, arsenic, antimony and bismuth, do not form p-pi multiple bond. Nitrogen, due to its small size, it can form p-pi multiple bond, but other elements do not form p-pi multiple bond. So these elements form case structure for their oxide. Like their elemental state, in the oxides, in their structure of oxide, they also form case like structure. Due to large size, they do not form p-pi multiple bond. Let us discuss the oxide of nitrogen. That one, first oxide is N2O. N2O, that is nitrous acid. N2O, that is nitrous acid, having oxidation state +1. This exists in the structure, that is N, one N containing minus charge and one N containing plus charge. In resonance, if minus charge is transferred to this and this double bond is transferred to oxygen, then this structure happens. Then this is the structure, resonating structure of this nitrous oxide. It is a linear molecule and unsymmetrical molecule. Because unsymmetrical, you can see that this is not symmetrical in nature. This is a unsymmetrical molecule. Then another oxide, that is nitric oxide, that is NO. Nitric oxide NO having oxidation state +2. It contains one unpaired electron, in that is odd electron, which makes gaseous nitric oxide paramagnetic. That is, when nitric oxide exists in gaseous state, it contains one unpaired electron. You can see that in this case there are 3 electrons. 2 electrons is of oxygen and 1 electron is of nitrogen. So there are one odd electron or one unpaired electron. Due to presence of unpaired electron, it becomes paramagnetic. But in liquid state and solid state, it exists in dimeric form, that is N2 and O2. Exists in dimeric form, that is in N2O2, and becomes diamagnetic. Due to dimeric form, they forms bond with each other and becomes diamagnetic due to absence of unpaired electron. You can see the dimeric state, that is, this is the N2O2 structure, for which the odd electron bond each other and it becomes diamagnetic in solid and liquid state, but in gaseous state it exists in NO form, so it becomes paramagnetic due to presence of one unpaired electron. Okay, next comes to another oxide, that is N2O3. N2O3, this is known as anhydride of nitrous acid. What do you mean by anhydride? Anhydride means loss of water molecule. From nitrous acid, if I loss water molecule. What is the formula of nitrous acid? That is HNO2. In HNO2 molecule, you can see that in HNO2 molecule, if we lose H2O molecule, then the remaining product will be N2O3, for which it is known as anhydride of nitrous acid, and it is unstable because it decomposes into NO and NO2. It is unstable because it decomposes to give NO and NO2. It exists in two forms, that is symmetrical form and unsymmetrical form. This is the symmetrical form because in both the sides they are same atoms are placed, but in this case it is an unsymmetrical form because on both the sides there are not the similar atoms are present, so it is an unsymmetrical form and it is a symmetrical form. Next comes to another oxide, that is NO2, that is NO2 nitrogen dioxide, having oxidation state +4. This molecule has V-shaped structure and has unpaired electron and paramagnetic in nature. You can see the unpaired electron. Due to presence of this unpaired electron, this is paramagnetic in nature, having V-shaped structure. Next comes to another oxide, that is N2O5. N2O5 having oxidation state +5. It exists as symmetrical molecule in gaseous state where NON bond is linear. NON bond is linear. One dirty bond with O is upper, one dirty bond with O is lowercase, one double bond O is in upper level, one double bond O is in lowercase. So in both the cases they are symmetrical and NON bond is linear, and it is also known as anhydride of nitric acid. It is also known as N2O5 is also known as anhydride of nitric acid. Nitric acid having formula HNO3. From HNO3 we can lose, anhydride means loss of water. In the loss, by losing water molecule, HNO3 nitric acid forms N2O5, that is dinitrogen pentoxide. So N2O5 is otherwise called as anhydride of nitric acid. Anhydride of nitric acid. You can mention it. Next, in solid state, it exists in ionic form. In solid state, it exists in ionic form, that is NO2 plus and NO3 minus state. In ionic solid state, it exists in ionic state or ionic form, that is NO2 plus and NO3 minus. N2O5, the one becomes NO2 plus and one becomes NO3 minus. So plus minus giving neutral, that is N2O5 in solid state exists in this form, NO2 plus and NO3 minus state. Okay, so these are the oxides of nitrogen. Among the oxides of nitrogen, N2O and NO are neutral in nature, and N2O3, N2O4 and N2O5, these are acidic in nature. In the next video, we will discuss preparation, properties and uses of nitrogen. Thank you.